Welcome to the University of Michigan Dentistry Podcast Series, promoting oral health care worldwide.
As you know, the connector is that part of a bridge which joins the Pontic to the retainer, or may join two Pontics together. On the model which I have here, we have a 3-unit bridge with fixed connectors, with which you're quite familiar. This gives a solid 3-unit bridge with soldered or cast connectors. On the other side of this model is a 3-unit bridge with a semi-rigid connector between the molar Pontic and a bicuspid retainer, such that the bridge is made in two sections. First of all, the retainer on the bicuspid is cemented into position, and then the rest of the bridge is cemented in position later. This offers certain advantages, and this presentation will discuss 4 uses of this semi-rigid connector. But first of all, let's take a look at the diagram over here, which shows an enlarged view of the keyway of the semi-rigid connector. And we'll discuss this in greater detail at a later point. But I think you can recognize here the retentive key form, the fact that it's about twice as long as it is wide, and that it tapers from occlusal toward the cervical, and is here being cut in a class 2 inlay on this tooth. If we take a look now at the other diagram over here, you see the keyway from the occlusal, and here is the Pontic with the key being placed into position there. And you can see how there is a locking relationship between the key and the keyway, so that it's not possible for the bridge to pull out of position in this direction. It does, of course, allow a little freedom of movement in this direction and in an up and down direction, occluso-cervically. Now, the 4 uses of the semi-rigid connector which we want to discuss. First of all, it's used in reconciling draw problems between tilted bridge abutments. You're quite familiar with the mandibular molar situation where this is tilted, and it may sometimes be difficult to cut preparations on the molar and on the other, say, bicuspid abutment, and to get these lined up so that you have a common line of draw. The semi-rigid connector enables you to make an adjustment in this relationship and place bridges in situations that otherwise might be difficult. The second use that we want to talk about is in the use of the semi-rigid connector in the use of just 2 surface retainers, more simple retainers, which would not have sufficient retention if they were attached to a bridge rigidly. But by interposing a semi-rigid connector, it's possible to use these smaller, less retentive retainers in certain situations where they have definite advantages. And the third use is to divide extensive bridges into convenient sections. If you're building a bridge which is going to perhaps go all around the maxillary arch, it may be convenient to build a bridge which can be cemented in a series of sections which interlock with each other. It has advantages at the time of preparation and aligning abutments. It has advantages in the time of cementation of handling smaller sections. It has advantages in maintenance. If one part of a bridge develops problems, it can be removed independently of the rest, and the problems corrected and then reinserted without disturbing the whole prosthesis. And then again, the 4th use is in repairing bridges. Extensive bridges which may develop problems can often be repaired by cutting off a section of the bridge, cutting a semi-rigid connector into the remaining part and replacing just a part of the damaged bridge. So those are the 4 uses which we'll look at in greater detail. The use of the semi-rigid connector to reconcile draw problems between tilted bridge abutments is illustrated in this diagram of a typical clinical case, in which, through the early loss of a mandibular first molar here, the second molar has tilted mesially. And in doing a preparation on this tooth here, and this might represent a cross-section through a complete crown or through a 3/4 crown or even through an MOD protective cusp inlay, there are limitations in the cutting of these axial walls in these 2 situations, because of the relation to the pulp tissue here. This is about as far distally inclined as it's possible to make this mesial wall in this particular clinical case, so that the line of draw of this preparation is dictated by that mesial wall and represented here by this arrow. On the mandibular premolar here, and quite frequently in these cases the mandibular premolar will be tilted a little bit to the distal. Similar problems arise in the preparation in getting these aligned, but there is also another problem related to the contact relation here. And a critical point determining the line of draw of this retainer here is the cervical cable surface angle just here and its relation to the contact point. As this draws from here on a fixed bridge, that would have to be able to go past that situation. Now, if I put a line in down there between that cervical and the contact point, I think you can see that that does not line up, is not parallel with the other arrow. So it would not be possible here to use fixed connectors between these two retainers. Now, by using the semi-rigid connector in this situation here, it's possible to cut the semi-rigid connector and parallel the line of draw of that connector with this mesial wall of the molar abutment here. So that then we have a bridge in two sections in which this can be cemented in on its own line of insertion and clear this problem situation here. And then after that is cemented, the rest of the bridge with the Pontic and the semi-rigid connector can be inserted on the common line of draw between the semi-rigid connector and the molar preparation here. The use of the semi-rigid connector with a two-surface retainer is shown in this diagram here, which represents a maxillary bridge in which the second bicuspid is being replaced, with the first bicuspid and the first molar as the abutments. Supposing in this clinical case that the first bicuspid abutment here had no previous caries and no previous restorations, there would be much to be said for a very conservative preparation, such as a Class II inlay, which involved just the occlusal and distal surface of this tooth. However, such a retainer used with a fixed connector would not stay satisfactorily in place. By interposing a semi-rigid connector here, which would break the stress between the main part of the bridge and the Pontic and this mesial retainer, it's possible to use a two-surface gold inlay on the bicuspid here and so expose the minimum amount of gold and also cut the minimum amount of tooth during the retainer preparation. Now, if we remove the labial surface of this tooth, you can see in cross-section now a typical Class II inlay with its occlusal key and the distal proximal box down here, and the semi-rigid connector has been cut into this area here. Now, if we move down the posterior part of the bridge, you can see the relationship between the key and the keyway. It doesn't appear retentive here, of course, because the retentive form is in the labial proximal box wall, which has been cut away. This breaks the stress. It allows a little bit of movement between the posterior part of the bridge and this retainer here, so that this will remain satisfactorily cemented in position during normal function. Now, if we place back again the labial surface here, I think you see once again the advantages of that type of retainer in this situation. No gold exposed on the mesial, the labial, or any of the margins in that situation. So this then is the use of the semi-rigid connector to enable the use of a simpler two-surface retainer in this particular bridge case. This diagram shows the use of the semi-rigid connector in sectioning a 7-unit maxillary bridge. You see on the diagram here a pin-ledge retainer on this central incisor here, a Pontic, another Pontic, a pin-ledge retainer on this cuspid, a 3/4 crown on this bicuspid, a Pontic, and a 3/4 crown on the molar tooth here. The bridge is divided into two by a semi-rigid connector at this point. So the bridge is cemented in position as an anterior element, and then the posterior element is cemented in. The interposition of a semi-rigid connector at this point could be used to reconcile draw problems between anterior and posterior abutments if they existed. It facilitates at the time of cementation because the bridge can be cemented in two separate sections. It might also be helpful at a later point of time should anything go wrong with the posterior part, which could be removed and remade without disturbing the anterior section of the bridge. If we take a closer look at this semi-rigid connector here, I think you can see that in the design of the occlusal surface of the keyway, which you see in outline here, the functional morphology of the teeth on either side has not been in any way disturbed, nor has the contact relation here. And you can see that the occlusal surface of the keyway has been carved in wax and cast to give a definite marginal ridge relation across here, the occlusal embrasure in between, and a marginal ridge on the other tooth, so that there's no disturbance of the functional form of the occlusal surface or the proximal surfaces in this situation. So we see here then a semi-rigid connector used on a 7-unit bridge to divide it into a 5-unit anterior section, a 2-unit posterior section, with the advantages of reconciliation of draw if necessary, of ease of cementation in two sections, and of possible future facilitation of any repair problem that might arise. This diagram shows a case in which the semi-rigid connector can be used in repairing a bridge. This is a 5-unit maxillary bridge with a pin ledge on the cuspid, a Pontic here, a 3/4 crown on the bicuspid here, a molar Pontic there, and a complete crown on the second molar here. Supposing in such a case that this terminal retainer here came loose on the bridge and the rest was quite intact, the choice is in removing the total bridge in order to resolve this problem, or in cutting through the Pontic in this section. If the Pontic is cut through across here, the defective part of the bridge, including this retainer, can be removed. The problem identified and corrected on this abutment tooth, and the posterior part remade with a semi-rigid connector into the bicuspid here. This requires, of course, that the semi-rigid connector be cut in gold in the mouth on the distal surface of this tooth. Now, the cutting off of the Pontic here is critical in the positioning of the cut. Notice that this cut goes through the Pontic itself and does not involve the connector between the Pontic and the bicuspid tooth. So when this cut is made and this part of the bridge is removed, this retainer is still in position in the mouth with the connector projecting distally. Using suitable instruments, the gold of the connector is trimmed down in the mouth and the distal surface of that retainer smoothed and contoured as it should be. And then a semi-rigid connector is cut. The keyway is cut into this gold preparation in the mouth. An impression taken of the whole of this area and a bridge constructed with the key, which will then fit into there, so that this part can be removed, repaired, and re-cemented in position, now with a semi-rigid connector at this point in this situation here. It's necessary in these cases, of course, to identify that there is sufficient gold in the retainer here to allow of a semi-rigid connector being cut, of the keyway being cut in this situation. It's often desirable to cut perhaps a somewhat smaller keyway than would be done in the normal case where the retainer is designed specially for a keyway. So this then shows a situation whereby when one retainer on a fairly long span bridge comes loose, the bridge can be sectioned through a Pontic, the defective part removed, the surface here finished off, a keyway cut into there, the problems with this retainer identified and corrected, an impression taken of the whole thing, and this part of the bridge remade, cemented with the semi-rigid connector, picking up the connection with the last retainer of the anterior part of the bridge. We have discussed the four uses of the semi-rigid connector, and now we need to turn to discuss something of the design and the fabrication of the semi-rigid connector. It's important in using a semi-rigid connector to begin the design sequence at the time the tooth preparation is being done, So we have to regard tooth preparation as part of the designing of the semi-rigid connector. So far as the connector itself is concerned, we have to think in terms of the keyway in the retainer and the key itself, which belongs to the Pontic. So all of these things are involved in the designing of the semi-rigid connector. Let's take a look, first of all, at the question of tooth preparation. The semi-rigid connector would normally probably be used with a Class 2 inlay, possibly with a 3/4 crown, or even a complete crown. Now, there are special things to watch in each of these. In the case of the Class 2 inlay, it is important in cutting the proximal box to recognize the need to create sufficient space for gold large enough to receive the semi-rigid connector, to accept the keyway part. Similarly, if a 3/4 crown is being done, then it may be important to make sure the design includes a box on the appropriate proximal surface, and that the box is both wide enough and deep enough to accommodate the keyway in the gold casting. So far as the complete crown is concerned, again, the importance is to make sure that there is sufficient bulk of gold on the appropriate proximal surface to enable the keyway to be cut. And this may require the cutting of a box in a complete crown preparation where no such box would otherwise be cut. So the important thing here is to remember at the stage of tooth preparation to design the retainer so that there will be adequate room for the keyway of the semi-rigid connector. Let's go back now to the question of the connector itself. And this really has two sets of areas to look at. First of all, those on the retainer itself, which consist of the facing and the keyway, and then on the Pontic, which of course has the key and the faceplate. Let's take a look first of all at the part on the retainer itself. And here you see a keyway which has been cut on a Class 2 inlay. The characteristics of this are that it should be about twice as long as it is wide, that it should have this retentive key form, that there should be a taper of about 5 degrees from cervical to occlusal to facilitate the waxing and the drawing and the insertion of the keyway into that. Notice also that usually a flat surface is cut on the proximal surface of the inlay, 3/4 crown, or whatever it may be. And it is into that flat which the keyway is cut. This area here is sometimes described as the facing. And as the keyway is designed and developed as part of the Pontic, there is often a part of the Pontic itself which fits over here, which we're calling the faceplate. Now, if we turn now to the next point which we need to look at is on the Pontic itself, the key and the faceplate. And here you see the Class 2 inlay from the occlusal, and I think you can see the outline of the keyway in this situation. There is on this one a small flat across here representing the facing, and the Pontic, of course, needs to be designed and built with a keyway, which is made by waxing into the key itself, and this will fit into position down there. Now, depending on the size of the facing itself, there may be some extension of this key out in this direction on either side. And perhaps that aspect, the facing, can be best explained on this next diagram over here, which explains the reason for that faceplate. It's most commonly used and found in the case of the tilted mandibular molar, when the keyway here is being aligned with the line of draw of the mesial proximal wall of the crown on this preparation. In order to cut a keyway on here that will draw in line with that, it's necessary to cut a flat on the surface of the retainer here, so that that part of the Pontic against here will slide up that face along the same line of draw as that. If that is not done, then you may have undercuts here which would prevent the key from withdrawing from the keyway. If this needs to be a fairly extensive cut into here, as it may be if the molar is tilted markedly, then this part of the tooth needs to be rebuilt as a part of the key itself. and so the key would have this extension, the faceplate, around either side. If we can just go back to the previous illustration, we can emphasize once again the occlusal morphology of the key itself, the development of the normal marginal ridge on that tooth and on this one, and the occlusal embrasure left in between. It's most important to restore this morphology in making the key and the keyway. Now that we've discussed the design of the semi-rigid connector, it remains merely to look at the fabrication. And this can be seen, I think, on the following diagram. The gold restoration for the retainer in which the semi-rigid connector is going to be placed is fabricated first in building the bridge. And this diagram would represent the gold class 2 inlay in position on the die on the working laboratory model. The first step is to cut a facing on the proximal surface where the semi-rigid connector is going to be placed. And as you've seen previously, this facing is lined up with the line of draw of the bridge. Once that is cut, a 170L carbide burr is taken and placed in a central position on the flat at the necessary depth for the keyway, and a cut is made into the tooth, crossing the marginal ridge in this direction. With the carbide burr in position in this cut, an extension is made to the lingual and to the buccal to begin developing the retentive key form of the keyway. The essential form of the keyway has now been established, and it remains only to round off the sharp axial line angles and to finish developing the flare and to open the entrant angles and smooth these off. The final finishing of the keyway is achieved with a 600L finishing burr, in which all the surfaces are smoothed off, it's checked for adequate taper, smooth entrant angles, smooth axial line angles. It is then ready for the next stage of waxing the key itself. The preparation of the keyway has been visualized from the occlusal surface, and perhaps it's helpful just to return to a proximal view of the finished keyway. I think you can recognize the characteristics now, the length being something about twice the width of the preparation. Here is the facing. Notice the degree of taper and the retentive key form, the rounding of the entrant and axial line angles, and the preparation is now ready for waxing. The rest of the bridge is fabricated, and as the Pontic, which lies just in this situation, as that is waxed, an extension is waxed into this keyway. It's necessary, of course, to lubricate the gold in the normal manner, and when the Pontic is completely waxed and sprued, it's removed along with the key from the keyway and cast in gold. It may be helpful at this point to return from the enlarged diagrams to the original natural size model with which we started. And we have here the Pontic with its key just on the end. I think I can hold it so that you can just see that key on the end. Notice the length and the retentive form seen from the occlusal. And then we have the other retainer preparation here with the facing and the keyway cut into that. You can see the retentive form there, and of course these two fit together to give the 3-unit bridge with a semi-rigid connector between the molar and the bicuspid. Just to summarize the design and preparation of the semi-rigid connector, we have emphasized the need to begin the designing at the stage of the tooth preparation, and so far as the connector itself is concerned, there's the element in the retainer, the keyway, and the key, which is a part of the Pontic. Just to go over the question of tooth preparation briefly, it can be used in class 2 inlays, in 3/4 crowns, and in complete crowns, and the important thing here is to make sure that the box of some type is available of sufficient size to receive the keyway when that has to be cut in the gold. So special attention is necessary then to tooth preparation. So far as the connector itself is concerned, the part belonging to the retainer, remember the facing, which has to be cut in line with the line of draw of the bridge, the retentive keyway, which is then cut into the facing and into the retainer itself, and then the key and the faceplate, which are waxed up as part of the Pontic and fit into and complete the semi-rigid connector.
You've been listening to a presentation from the University of Michigan School of Dentistry, which is dedicated to supporting open learning and open educational resources. This recording is licensed under the Creative Commons. It may be reused and redistributed for nonprofit use. Please attribute materials to the University of Michigan School of Dentistry and redistribute under this same license. For more information on how this and other University of Michigan School of Dentistry recordings may be used, visit www.dent.umich.edu/license.